Hello. Welcome, welcome. I'm just hosting tonight, so we will be having a enjoyable and fairly, hopefully enjoyable anyway. We already have one of our guests. In this corner, Professor Nixy.
Are you ready to rumble?
I don't know.
Want to thank you for hosting this. This should be a lot of fun.
Of course, I mentioned to Danny and to my wife that, yeah, I actually don't really care about planetary physics, so I'm going into this very neutral.
I think it's awesome.
Yeah, so we'll see how it goes, and we'll see who makes the most convincing arguments. We are missing Robby. Um, there he is. So is it 2v1?
No, it's just me and Robby.
Oh, wait, but Jorge was in the group chat.
Yeah, we were thinking about doing two versus two, but
Oh,
I
because
think
I
it's
was
going
going
to
to be
be
in it. Yeah, yeah, yeah.
easier this way.
Excellent. Right. So we'll start in just a few minutes or so. But I'm actually going to get some timers. Do you guys have opening statements prepared?
Yes.
What I wanted to ask is, can I use my other account because I do want to show some images? Would that be
Sure.
possible?
I'm
Yeah,
okay
sure.
with that.
Like, do you want to be on it simultaneously, or?
Yeah, because then I can mute one. Well, I don't know. I don't think I need to show my face actually.
Yeah, I mean, so you don't have to. So I can just make you big. Oh, yeah. I mean, so whatever works best for you. I'm happy to bring up whatever you need.
Okay. I guess yeah. I guess I'll just maybe I should turn my camera on instead of being rude. I'll just do that.
And I can't thank you enough for letting us do this on your channel. That way it's impartial.
I'm happy to. Of course, of course. Remember, everybody, to like the live. Let's get those numbers up. Thank you. Unnecessary, but thank you. Right. Okay. So, Robby, so do you still want to join on your second account, or?
Yeah, I might do that because then I can put this one in, and then I can actually have my other one where I feel like
Okay.
I'm also participating. Yeah, give me 1 second. I'll be there in a second.
Sure. Oh,
Sorry about
by
this.
the way, we won't be accepting guests today. It's just I'm hosting a debate between these two lovely people, and we'll be getting started in just a minute. So I figure, is 3 minutes enough for opening statements each?
Sure.
I think so.
Okay, so we'll do 3 minute opening statements, and then we can maybe do 5 minutes of. Actually, no, I think we'll just go to a back and forth. That's much more
Yeah.
fun. Yeah, I guess since I probably should have organized better, but you know.
Eh. Yeah.
Yeah, so it looks like we're gonna go for about 90 minutes. If we have if we have content for 90 minutes, we'll do 90 minutes. We can go longer if necessary, if you guys have stuff. Otherwise, and then we can open up for a Q&A at the end. I can bring up guests that want to that have questions, and we can do that. How does that sound?
Excellent. That sounds perfect.
Yeah, and let me change I guess my face doesn't need to be the big one, right? Let me change go to the panel mode. There's a way to do this, if I can figure it out.
Welcome in, everyone. Tap that screen. If you don't follow Dr. Blitz, please give him a follow. If you follow me, he has amazing content. And follow Robby Mars, even though he's got a smaller gravitational field. Give him a follow.
All right, so we're switching to the grid layout.
Oh, shit, 1 second, sorry, my bad.
He should
My
lose
bad.
just for that.
By the way, as a well, never mind. Nixie, do you have a second account that you would want to join on, or? Okay.
I don't have a second account.
Okay. I guess you've never been banned. All right.
No, I've never been banned.
So, who wants to go first?
Nixy, you can go first.
Okay.
All right, so just for everybody who's just getting here, because we have about almost 500 people here, we are going to be, well, I'm hosting a debate between Robby here and Nixy. I don't know if you guys know Robby and Nixy. Robby is currently a grad student, if I'm correct, studying planetary physics or solar physics, maybe?
So I'm doing it on high mass X-ray binary systems.
Okay, there you go. And Nixy is well, you guys probably know him more than you know me, an astronomer who has discovered numerous things, has taught at the college level, is a very clever fellow. And they're going to be debating over which is a better planet to terraform, Venus or Mars. So whoever wants to go first, feel free to do so. And I'm going to start a 3-minute timer. Nixy, go ahead. Let us know which one you're defending to.
All right. So
Time's
I'm going
yours.
to be I'm going to be talking about Venus. But first we need to talk about what terraforming means. Terraforming means to make Earth-like. And that's the most important part of terraforming. It's not to make colonizing it with domes. It's about changing a planet so that human life and life that humans need can exist in the most native environment possible. And Venus is our sister world. It may not look it from its atmosphere, but once we change that, you're going to see that Venus has so many more advantageous situations, because not only its gravitational field, but its location in the solar system is going to make it a far better world to terraform. Now, terraforming is not simple, and we've just started discovering the techniques that make it necessary. So in this debate, you're going to learn about Venus, but more importantly, you're going to learn about the Earth. And what we need to make sure that we do in this debate is focus on the word terraforming and how the world, aka Venus, is going to become a second world for humanity and truly terraformed.
Nice.
You
I'm
still
just
have a
going to
minute and a
go.
half if you want it. Otherwise, we can move on to Robby.
As soon as Robby's ready, I try and keep my opening statement short.
All right,
Awesome.
Robby. Well, whenever you want. You're all
So
good.
I guess just to sort of first note, if somebody wants to follow my slides, which I will go through the slides a bit later as we address each of the points, I've shared a link in my profile, so you can go in and you can click on it and you can see all of the notes and all of the resources of which I've referenced all my work from. So you can click on that and that will be available for you, so you can follow some of the things that I'm talking about and actually check out the references. Yeah, so as Nixy pointed out, I agree that terraforming has a definition that basically hides subtleties. So it's basically to change the planet to Earth-like as possible. Now, it can be broken up into subcategories where you have planetological terraforming, which basically means that you can change the planet without human intervention for like large geological times. And so humans can live on the surface without any technology and maintenance required. Whereas habitable terraforming is basically, it requires constant maintenance and basically human intervention with technology that helps it to stay stable, and people can live on the surface of Mars, for example. But yeah, I guess some of the key points that I want to argue for Mars is that Mars lies in the habitable zone of the solar system. There's 2 planets, Earth and Mars, and Venus sits outside of the habitable zone. And this makes Mars one of the stronger candidates. And then secondly, it's the closest planet in our solar system that is Earth-like, so it requires less work to terraform it. And I guess a lot of the technology available today could help us actually change this planet and utilize it in a way that is terraformed to a point where humans can live on the surface. So I guess when it comes to comparing the planets, which Nixy and I will address some of these points, we will go through them, point out the weaknesses and the strengths for each planet, and discuss them in detail. But as we address that, I've made available some, I guess, references for people to work from and to see if they can follow what we're talking about. later on. But yeah, I guess that's my opening statement.
All right, well, thank you both of you. So we're going to move on to an open discussion, and then at some point, if things get rowdy, which I hope it does, we might have to do a scheduled back and forth. But why don't we start the conversation with what exactly are the requirements for terraforming?
Do you want to take that first,
I'll leave it
Nixy?
to the two of you.
No, your turn.
Okay, so yeah, I guess like I don't know if you can see that, but basically there's like a definition that has been published in this paper here, which gives you like the definition for terraforming. So it's basically turning a planet into an Earth-like planet. And this hides subtleties. And basically, when I spoke on my opening statement, these are the distinctions that I think that Nixy and I will talk about to sort of flesh out which one is the better candidate for terraforming. So when I was talking about habitable terraform, it basically leaves the planet adapted for human habitation, but artificial shortcuts and needs maintaining. So this is what we don't want to resort to, and we want to get to as close as planetological terraform as possible. And so, at least from my perspective, both planets will actually fall under the habitable terraforming definition. But I guess we can try to address this as we go further and further into the discussion.
I think the most important part of that is which world is going to allow for the least amount of maintenance, because the more maintenance that a world has, it may take more maintenance for a world to become terraformed, but the ongoing maintenance so that society isn't spending time maintaining the world, but the world can maintain itself. And I think that's where Venus is going to shine in this conversation. Is it's going to be a little harder to terraform, but long term, it doesn't have a lot of the issues of the gravitational well that you're going to have to figure out how to solve. I only have to figure out how to solve the orbit and the atmosphere, and then it will self-maintain. So I think planning long term, because when you're taking on a task as great as terraforming, it needs to not be, oh, can we get there in 1,000 years? Is how can we get millions or hundreds of millions of years of life out of the world if we're going to put this much resources into the world?
Yeah. So, I think I would agree with you there. One of the points that you brought up was the gravitational well. And specifically, what I want to address here is that when we're talking about the gravity of Mars, we've constrained it to being about 38.5% the gravity of Earth. Now, I think it's important to note here, extremely important, in fact, that we have no data on this particular point and how this could affect the human body. What we do have data on, in fact, is actually the gravitational pull from the moon, and then also experiments that have been done in the ISS, and basically simulations of microgravity here on Earth. And through these, they have demonstrated that what could be of concern is conception. And so if you, maybe I'll go down to this slide here. Where is it? So there's a paper. I've got one of the links in there that you can look at that basically shows that there were two studies that were done where there was that showed no effects of conception that occurred on the ISS in rats that were tested. And then there were 4 studies that showed negative impact. And this is because during egg fertilization of the rats, there can be it's extremely sensitive due to the cell structure, and these seem to be affected by gravity. And so they had to do these studies, and what it showed is that it increased basically the implantation of the egg onto the uterus lining was decreased. And because it was decreased, they showed that this could be a potential issue if you're subject to low gravity. So there were 2 studies that showed nothing, but there were 4 that showed something. And so ultimately, we don't know, and we have to go and collect data. So what's important is that if we do move to Mars, we have countermeasures to to cater for any negative effects or to increase the probability or chances of conception and having a successful birth on there. So the countermeasures would be to introduce like artificial wombs. I know that doesn't sound too inviting, but you can look at these images here. It is a technology that has been that is in full development now, where you can give the developing embryo the hormones required and inject also basically help build up the immune system. And so these are things that I've put in place. And if there are effects like with bone loss and muscle loss, there are also these exoskeleton devices that you could implement until that human being becomes adapted to its new environment. So these are just countermeasures to help any of the issues that may arise when we do if we do indeed try to move over to Mars. And ultimately, we don't actually require this. People would still be able to live on the surface, but we're just aiding in the health and making sure that people can actually adapt to the environment safely without as much, issues as possible.
So we know that less physical activity is going to reduce bone density and muscle structure in a Mars gravity environment where you have 38% compared to Venus where you have 90%. You would have some degradation, of course, in Venus because you're in 90% the gravity well, but we're talking about 40%. So what is that going to do to humans and to women who are bearing children? The amount of stress given in childbirth, you're probably only looking at C-sections. You're looking at the changes of humans. And a child who's born on Mars is not going to develop the bone structure and muscle structures that they would on Earth or on Venus, where they would be 80 to 90% the same strength because of the gravitational field. I think we're underestimating the effect based off what we've seen of astronauts who spend a year aboard the ISS. Yes, it's zero gravity, but we're not talking, we're comparing 40% to 90%. And I think you're underestimating the effects on the human ecosystem, skeleton and bone structure and muscle structure, that if you were born on Mars and you live for 20 years and you want to go to grandma's 70th Christmas or birthday on Earth, you're probably not going to be able to come down to the surface and celebrate with grandma. Where with Venus, you're going to be able to come back to Earth. You may be winded a little more. It's like going up to high altitude. So I think we need to also focus on, can you create a society that can go between the worlds? Otherwise, we've created two worlds, but the societies can't really interact except in space. Martians can't really go to Earth, and Earth people can go to Mars, but their progeny cannot come back. I think that's the weakest struggle that Venus has. The other advantage that Mars has, being in the inner orbit, its average distance is 50 million.
So just to keep things organized, what I think a good thing to do would be to keep focus on individual topics. So right now we're talking about the gravitational effect on humans and on human society. I think so after you're done responding to that, since you brought that one up, Robby can present another aspect that's important for terraforming, and then we can keep going. So continue.
Okay, no, good. Way to keep me on task. By the way, everybody tap Dr. Blitz's face. Let's get more likes in here. Thank you for hosting this. If you don't follow Robby Mars or Dr. Blitz and you're a follower of mine, they have amazing content. So I think we do need to do that studies on Martian gravity on the moon to find out if humans can reproduce and can they come back to the Earth, because that changes us being a multi-planet society. We would be two different planet societies, and I think it's important to have one society. Robby?
Yeah, Robby,
Yeah,
do you want to
so
respond to that, or do you want to change topic?
yeah,
Both are option.
I'll do a response just to sort of illustrate the point that I was trying to drive there. I think like the key factor is there are also studies that have shown that for basically bacteria structure that low gravity can be beneficial. And so this is one of the things that we have to recognize is that we just don't have data for 40% gravity. So we can't make assumptions without the data and drawing conclusions that it is going to be terrible. I think what we need to what we have to do is wait till we get there and see how the human body responds to a new environment, and just make sure that we have the safety measures to counter these effects as much as possible. That's all we can do. But the thing is that there might even be some advantages that come from being in low gravity. So, for example, you could get big trees that can grow taller, and just little things like this that may show some subtle differences. But until we actually get there, we can't really draw conclusions. So I just want to make that extremely clear for this point here. But secondly, one of the issues, and maybe I'll address two things here. The thing is that if we are looking to be a species that wants to start to colonize all these different planets, we actually have to go through the process of dealing with different gravitational fields because or other planets that might have that range. And so this would be a stepping stone and a learning curve for us to actually figure out how this happens. So I think if we do go down this route, that's what we should consider, that it will bring us new data, at least for us, if we do become a species that tries to spread out through the solar system. But secondly, what I want to speak about is that if we are going to Mars, the journey between Mars and Earth, that's like it ranges from the time given ranges from 6 months to 2 years. And being exposed, right now we don't have the defenses, the protection to deal with the extreme radiation from cosmic rays or solar winds that humans are subject to. So we still have countermeasures like shielding, but the shielding that still enables 70% of that radiation to still basically be humans to be exposed to that radiation. So if we are jumping between planets, we have to have built up an infrastructure that can protect us and have better shielding. And at the moment, the risk of traveling from Earth to Mars comes with high risk that if a solar flare occurred during that journey, there could be lethal doses that the astronauts could encounter. So it's not as simple as just going back and forth. So if you do end up migrating to Mars, maybe it's not so safe at this point to be going back and forth. But let's assume that there is basically a safe haven between these two planets for the rest of this discussion. I think that's a good assumption we can make. But it's just clear to recognize that those defense mechanisms aren't developed well enough to protect us extremely well.
I think this is actually a good transition for a second topic, which is the question of radiation. I imagine that you guys have both looked into this. There are obviously radiation concerns just with space travel in general. I'm curious if you guys have thoughts about whether or not whether Venus or Mars will be a better option with regards to human safety, what kind of radiation shielding might be available, we might be able to make, etc. So I'm going to let Nixy take this one because Robby started the last one with regarding gravitational effects on humans. So go ahead, Nixy.
All right, so let me talk a little bit about the way to terraform Mars or Venus, because if we're going to talk about radiation, we need to get into how are we going to terraform the world. We're not going to terraform Mars by landing on it and building factories to get rid of the atmosphere. We're going to slam asteroids into it. By slamming asteroids into it, we're going to push it into the habitable zone, which is only 5 million miles away. It's not very far. It's going to take tens of thousands of years to do, and we can do that from sitting on our...
Did you say that to terraform Mars, we will slam asteroids into it, or to terraform Venus?
Terraform Venus, I'm sorry. I misspoke. So by putting asteroids and hitting Venus, we're going to change its orbit. We're also going to put a lot of dust in its atmosphere. That dust is going to create ice ages, and that's exactly what we want to do, is keep a continual ice age, where the carbon dioxide in Mars's atmosphere is going to freeze at the poles first,
Venus
and then when Venus, sorry.
Remember
I'm
your
sitting here
side.
looking at Robby Mars and Robby music. So Venus is going to get frozen at its poles with carbon dioxide, just like what Mars has on its poles. And then we're going to slam another asteroid into it, increasing its spin and pushing it out of its orbit more and more away from the sun. Each one of those impacts are large impacts, and it's not that hard. Today, we can change the orbit of asteroids using two different methods. Putting an object in orbit, in a highly elliptical orbit around an asteroid, will change its position. We can also slam small objects from rockets into asteroids to change their orbits. We can do that today. We need to do it at a greater scale than we do today, but the technology exists today. You can look at the DART mission by NASA. So by doing that, we're going to freeze all that carbon dioxide into the poles and cover it with meters of dust with these impacts. So rather than have to risk people to terraform Mars, we're going to let the solar system do that. Once we get that frozen, we're going to slam a comet in it. A particular comet, C 2014 UN 271, which will contain enough nitrogen and hydrogen in it to start creating oceans on the world. So we're looking at a terraforming over tens of thousands of years, moving the planet closer to the Earth. And because it's closer to the inner part, we're looking at the closest approach of Venus is every 600 days instead of 800 days on Mars. We're looking at it's going to come closer to Earth more often, and its average distance to the Earth is closer. So the transfer windows are longer, quicker, and easier.
Yeah, I guess I've just got a couple of questions, if that's okay for us to address these.
Go ahead. Yeah.
So I guess one of the questions that I have is, I guess, like, from what I understand with the technology, with the DART mission, and all of the techniques, like with the electric sail and the gravity tractor, all of these are working with bodies that are rather small. So the scales that we're talking about require an extreme amount of resources if you're trying to scale that up to move these large bodies. And so the other thing that I want to point out is that, maybe I'll go to the slide. Yeah, so like this here is like of the DART mission. I don't know if you can see it. It's probably hard to see there, but you can see like this solid line that actually represents the orbit prior to the DART satellite impacting Dimorphos here, and this dash line is the orbit's change. So what we're dealing with is an extremely, for the scale of what we're dealing with, the impact basically had, the asteroid that it hit had a radius of 85, I think, 85, I can't remember now, sorry. But the mass was 5 billion kgs, and it only shifted ever so slightly. So when we're talking about trying to move asteroids over the vast distances of our solar system, like this has to be scaled up to an extreme scale, which that technology right now, it's in its infant stage, but isn't at a point where we can actually achieve like just throwing asteroids and throwing comets into planets. This is something that's an extremely difficult task. I can see that in the future it could be possible, but these are working with bodies that are bodies and distances that are extremely vast if you were just trying to pull this off in reality. So I was just wondering, like, on the scale, like, what do we have to do to actually achieve this into the future?
So looking at that, and this is where I want to counter this, when we look at asteroid orbits, there's over 1,000 objects that are 1,000 kilometers, or a kilometer to 10 kilometers in Venus and Earth's vicinity. So we're not moving them from the outer, or these asteroids from the outer reach. We can literally, with a mission, and I did calculations on this, with about a 10 times impact of DART would have 4 different asteroids could impact Venus. So this is going to do 2 things. This is going to clean up the environment around Venus and Earth so that these objects don't hit those worlds. So objects like Apophis, that we know we need to move, we can move them to Venus, and this cleans up the environment. So we can help Earth and help Venus by moving these asteroids that are near Earth asteroids. There's over 22,000 of these bodies, and we do need to eventually clean them up so they don't hit the Earth. So why not get a benefit of both? Cleaning up the environment around Earth, because we live here and we're going to be here for a long time, and help terraform Venus.
Yeah. So, yeah, I definitely appreciate the thought there. I guess the thing that like the shift that happened in that orbital change from that impact, it was 2.7 millimeters per second, and I'm just trying to think, like, if we're changing its basically trajectory by a small amount now, like, the technology I see has potential for the future, but right now it just seems like an extremely difficult task for us to actually pull that off. And we don't have the technology that we could actually do that anytime soon. I think it would actually take far more development. And even though the asteroid belt is close by, this is still vast distances we're talking about here, especially if we're only shifting orbits by this amount.
We're not talking about the asteroid belt. We are talking about near-Earth asteroids that are near Venus, that are orbiting very close. Apophis is going to come within 20,000 miles of Earth in 2029. So I'm not going out to the asteroid belt. I'm dealing with the bodies that are nearby Venus, and changing their orbits by meters per second using the influence, and using something like Starship, which is very close, would have the velocity and mass required with 2 or 3 impacts to put these objects into Venus. So we're not that far away, and that's what I want to make sure people understand. DART went all the way out, and it impacted a moon with a very small impactor because we wanted to measure what the effects were, and we did a moon of an asteroid because we want to make sure we prove the technology safely, that we didn't create another Apophis. So I disagree that we're very far off. I think we're closer at being able to move asteroids than go to Mars or Venus.
Yeah, so again, like, yeah, I can see and I appreciate the technology and the development of this. I just think right now, for us to think that it's going to happen anytime soon, I think it should be made clear that this is pushing quite far out there into like a field where I think this still needs time for development. Not to say, though, just to bring up a second point, the amount of carbon dioxide on Venus is like, sorry, I have to go to my slide so I can remember.
90 atmospheres.
It's a large amount, and basically, sorry, where did I put Venus? Sorry about this. So it doesn't matter. I guess, like, the main thing is that if we are to try and reduce, get that carbon dioxide out of the atmosphere of Venus, you're going to be firing asteroids into. Yeah, and so in order to do that, like, that's going to require a lot of mass to achieve that, right? So you have to be moving big bodies, and so the scale of these bodies that you're going to be trying to impact,
or lots of little bodies. So remember, when a 1 kilometer asteroid like Apophis, which is relatively easy to move, and a ship like which you're going to need to get to Mars anyways. So the same technology needs to be developed for both these plans. So you're relying on the Starship technology to be able to even get to Mars. I need it to get to Venus. It can also be moved to move these 1 kilometer asteroids. Is going to create a greenhouse effect for 70 to 100 years. So I'm not talking about doing this overnight. I'm talking about doing this over tens of thousands of years. And then as we have each one impact, we're speeding up Venus, we're speeding up its rotation, and we can monitor and go, okay, we need another one. We need another one here. And what we want to do is freeze it out so that we're moving the planet, speeding up its rotation, and freezing it to the poles and covering it. It's not going to be one impact. Now, one giant impact can do a lot. A lot of little ones are going to allow us to fine tune that atmosphere and get the poles frozen with dry ice and then rock on top of it. Don't forget, the Earth has methane in the bottom of the ocean in the form of ice. If the oceans heat up too much, that's it for planet Earth. That's why we have to keep the oceans cool. So Mars has ticking time bombs. The Earth has ticking time bombs. Venus will have ticking time bombs, and that's why we need to do it over a long term. And with each impact, we learn more.
Yeah, I guess the thing that I wanted to sort of bring up there is that the concerns with carbon dioxide, like trying to deplete it, and I don't think it's as simple as just crashing an asteroid and then or multiple asteroids and then solving that issue. There is still going to be a lot of CO2 that will be locked in volatiles or whatever process that you go about doing it. And I'm not exactly sure how you're going to go about like either taking it off the planet or trying to bury it. But in terms of like trying to bury it, it has issues because the fact that if there are volcanic activity that's occurring underneath its surface, this would actually release it, and this poses a high risk in comparison to Mars and Earth. So this is one of the things that I think is not as simple as just burying it under the ground.
Volcanics haven't occurred.
It depends how you go about it.
Hold on.
I think there are.
The volcanics haven't occurred on Venus for 400 million years. It repainted its surface 400 million years ago. So we do have to do risk assessments of that, but we're not going to have a volcanic issue.
I think that the bigger problem that Robby's bringing up is how do you handle the how do you handle the CO2? So that's a good place to go to.
It's going to be in the poles, just like the dry ice is going to freeze first on the poles of Venus. This is how Mars froze, and then dust is going to settle on top.
I missed your point. I'm getting like maybe a bad connection. Can I just try to go to my 5G 1 second?
Yeah, sure.
I hope that's better. It keeps cutting in and out.
Okay. Yeah. So my question was just, it sounded like the objection that you were raising is that there is a lot of CO2 and that's a thing that needs to be handled. And so I was just asking if maybe that's a good place to move the conversation. And then lest we focus too much on shoving Venus down, there is a separate question of Venus has too much atmosphere, Mars doesn't have enough. So so after we finish talking about how we're going to handle Venus's atmosphere, I think we should move on to how we're going to handle Mars's atmosphere. So take away Robby, if you want to complain about the atmosphere.
Maybe you finish your point then, Nixy, because it cut out for me, and I do want to hear that with regards to solving the issue with CO2. That's my biggest concern, because I think it's a big risk factor.
Well, I think it's the second biggest part is the biggest problem but the impacts are going to do multiple things. One, it's going to move the world away from the sun, which we need to do. It's going to create winters because of the dust in the atmosphere, and because of the poles. it's going to freeze first on the poles. That dust will settle and free and cover it like it has on Mars, like it has on Earth, except we don't have dry ice there. And then with each impact, we're going to be burying it with more and more and more. And then we can always create an industry once we have enough of it frozen there that it's safe for people. We can always ship it to Mars because you're going to need it.
Yeah, I like that. That's a nice.
That's the transition.
Well, so I do have one question about Venus, unless you guys wanted to move on to Mars. I do have one question about Venus, which is about Venus's atmosphere. Namely, how do you figure that you will, I mean, the surface of Venus is what, 900 degrees Celsius? Fahrenheit, rather? How do you figure that you will get CO2 to freeze at the poles?
So doing the impact analysis, and this is what I did post in the Discord. I don't have slides in it. I slammed a 10-kilometer asteroid into the equator, and it put it in a nuclear winter where its surface got to about the average surface temperature was 20 degrees, and the poles were minus 200 degrees. Dust in the atmosphere will reflect that much solar light. When we look at the Chicxulub asteroid of the same size on Earth, look at the effects of the asteroid created the snowball as well. We've had periods of snowball Earth, so we have to hit it early with large enough impacts. And that's to Robby's point. I will give him credit that we have to move some large asteroids in the beginning. Those large asteroids are going to freeze the carbon dioxide out, and we have to impact it great enough to spin it up. But we can test that remotely. We're not going to have people on that world and go, oh, that wasn't big enough. Well, that's fine. There's only 10,000 candidates between Earth and Venus that we're clearing out anyways. And if we're going to clear out the asteroids between Earth, near Earth asteroids and Venus, because Venus can affect them, why not have it do something good?
So, I have to ask again, how cold did Earth get during the Chicxulub, or after the Chicxulub impact crater? Did it get to frozen nitrogen temperatures?
No, it didn't.
Okay.
But it hit in a very place where it created a lot of sulfur dioxide, and the Earth's oceans are what kept Earth so warm. Is all the water on the Earth. It's the number one greenhouse gas. It doesn't have water, so it's far more impacted because it only has CO2.
Okay.
No, that's
Robby,
a great question.
Was there any other questions that you wanted to ask, or any other rebuttals that you want to add regarding Venus's terrible atmospheric problem?
Yeah, I guess we can address some of those later. But I guess one thing I do want to say is that I do appreciate the advancements of the technology that we're trying to try and at least protect us from asteroids and comets that might come and impact Earth. So I think this type of research is in development. But I would just say, as a last sort of moving point to the next topic, is that I just don't see it being any viable anytime in the near future. It will be something in the distant future that would take long periods of time to achieve that. But it's definitely a great technology, and I would encourage anybody to go out and read about DART mission. It's freaking awesome.
So why don't we move on now to the atmosphere problem on Mars, which is another huge problem for Mars.
Yeah, I guess so just to sort of maybe give a little bit of a background. So the problem with Mars is some of the issues we need to overcome is the temperature. So it currently ranges between 210 and 147 Kelvin, and it's 100 times thinner than the Earth's atmosphere, and its pressure is 6%. So these are the first stepping stones that I need to address whilst trying to terraform Mars. And the problem is that because it's got a thin atmosphere, it's exposed to a lot of cosmic rays that come from like wherever. It could be galactic sources, and then also the solar wind that comes from the sun. So For Earth, we have the ozone and we have a magnetic field. And these are the two mechanisms that at least provide us somewhat of protection from like X-rays, gamma rays, high UV radiation, and then also cosmic rays, which are just charged particles impacting the upper atmosphere of Earth. So the first thing I need to address is actually trying to warm the planet up and pressurize it. And so in order to do that, it's going to take like a slow shift for us to actually get there, but also have the power to implement some of the planning that I think could help us to terraform its atmosphere. So first and foremost, there's these power devices that NASA's working with, which is the NASA Fission Surface Power. And basically, these can be carried along. They're supposedly light, and they generate 40 kilowatts of power. So at least as a first stepping stone for humans to reach Mars, we can at least take these with us to provide that power source that's required. But secondly, it would actually be having infrastructure there and setting up what do you call it? Factories that are able to at least make the stepping stone for us to terraform the atmosphere. So the first step would actually be getting humans there and making sure, or not even getting humans there, but sending 3D astro robotic 3D printers to actually build infrastructure for us. And this is something that they're going to utilize on the Artemis program or missions to try and build these structures. So what they did at NASA is they had a competition for companies to come together and use 3D printers that would cater against the internal pressure for Mars, because on Mars it's got a lower pressure on the outside, and actually we wanted to make it suitable for humans, so they're going to be able to hold that pressure. And so these are the structures that this company came up with, and this can be at least the first stepping stones to setting up infrastructure and homes for people if in the future we were to travel there. So this would be sent prior to us. These can be basically controlled externally. You don't have to be there, and they can set up at least the homes and the development on Mars for us. And this will basically make it easier for us, at least for that transition, without putting humans in harm's way. But secondly, we would try to sort of push that technology a bit further, send people over there and use those machines to start gathering resources for us so that we can start building these factories. Because one of the factories that I think is one of the strongest candidates for us to actually terraform Mars is to basically release CFCs, which is chlorofluorocarbons, and PFCs, which is perfluorocarbons. We actually do this on large scales here on Earth, so we're actually trying to reduce our production of greenhouse gases into the atmosphere. But secondly, in order for us to achieve this, one of the studies show that we need to release at least 1,000 tons per year into the atmosphere. And what we're trying to achieve here is to warm it up and actually get the greenhouse effect occurring. And the advantage of taking this method is that when we don't have on Mars, there's no plant life, there's no bacteria that's actually changing that CO2 into oxygen or into nitrogen. So what we have is a greenhouse effect that could be kick-started. And so it's been estimated that it would take 40 years to at least kick-start it with about 5,000 megawatts of electrical power. And so once we have that, you will start actually melting the dry ice at the poles of Mars. So there's a large amount of CO2 that could be released, and this will start contributing to the greenhouse gases being released, warming the planet up, and ultimately pressurizing it to a level that, obviously we're going to have to continuously pump for 40 years. This is the estimate that they calculated. And that will increase also the water will melt into the surface, and that water vapor will also contribute. And so this would be the first step, at least before I go on to the next part. We don't need to go into that, but I can just stay here and we can address some of the pressurized and increased temperature if you have any issues with that so far.
So So my issues are you were talking about me and needing technology. I just need spaceships to hit things. You have to build factories. You are going to have to get rid of the dust on the carbon dioxide on Mars to make it melt. It's not going to be just raising the temperature because a lot of that is below water ice, but a lot of it's below dust. There's billion years of dust on top of that, and that's why Elon Musk even said we're going to have to nuke the surface because you've got so much dust on top of that carbon dioxide. So when we were talking about technology and the amount of technology we each needed, I need the same technology you do just to get to Venus, but that's all I need to get to these asteroids to start changing their orbits. You have to develop all brand new technology. So I just want to make sure that people understand that a lot of the technologies that you need, I need, but then I'm going to have two benefits. I'm cleaning the solar system around Earth of potential impactors. You're creating a whole new industry.
Yeah, I guess like the thing is that the technology is there. That's a key factor, right? Like these actually have been tested here on Earth, and now it's to implement them on the moon. And so basically, the steps that were taken to get to the moon, this is the infrastructure that they're going to be using and the technology that they'll be using. The problem isn't that the technology is not there. The problem is actually that the distances we have to travel, and that's the problem. Like with getting that technology there. So the initial steps are actually to send this technology there first to build that infrastructure for us, and that's the idea behind it. But with regards to like nuking the poles, that was actually a terrible idea, and in the literature, it's actually spoken against that. That's not the right way to go about it, and that this way is actually more the more appropriate way because we don't want to be dealing with a
Well, I'm not saying nuke it, but that was his
yeah.
solution to get rid of the dust. You don't have a solution to get rid of the dust on top yet.
To be to be fair, Elon Musk has no good solutions to anything. So
He doesn't, but
take it
I'm
seriously.
just pointing out that you haven't
But
addressed the
it's
dust on top of the carbon dioxide.
in the literature, it still is. It actually, and you can go and look at the source. It addresses this
Mm.
point and say that it will actually melt the CO2. I mean, I haven't seen any counter arguments in the literature to this. So what I would, if there is indeed a case against this, this seems to be the most efficient and best way for us to go about it. There are alternative options that I can speak about, which is actually building like lasers and utilizing mirrors in space
Can I
because
get a
it's such a
freaking
finite
shark with
resource.
lasers?
Yeah, but I think that the key point there is that I'm trying to use as minimal resources and the technology to help us do this more efficiently and easier. Because I mean, I could point towards alternative options, but I'm just presenting here the most simplest and best way that we can go about doing this. And in the literature, this is what it's outlining as the best method.
And in that literature, and I want everyone to know that Blitz has been made aware of the literature. Robby, we are all using off the same literature
I
here.
have not read any of it to stay in the dark intentionally.
But everyone tap that screen. Thank you for gifting me. Thanks for gifting Robby and Blitz. Blitz, thank you for hosting this. If you don't follow any of us, please consider giving us a follow. In that literature that you did give me, I don't know if you read some of the peer review notes that there is a lot of dispute whether it will melt based off the dust coverage. So that I just want to call out that may be an issue.
Yeah, yeah. I think
Now,
one thing that I
oh, go ahead.
did notice just before we move to the next point is that it does state in one of them that we don't have the technology, but they specifically leave out this option here because they didn't. I don't know why they didn't address it, but they left this out because they said it wasn't of concern. I don't know why, but nevertheless, that's the last closing point for that.
Now, I have to ask a question. I asked hard questions for the Venus Defender. So regarding Mars, there is the issue of radiation, right? Cosmic rays. Now, an atmosphere will help, but we do know that cosmic rays are, at least or solar wind anyway, and cosmic rays are both significantly deflected by the magnetic field, which can help protect an atmosphere. How do you propose that the atmosphere will be protected from being stripped again? Because my understanding is that Mars used to have an atmosphere, but it was stripped by its lack of magnetic field. How do you propose to solve that problem when Mars does not have a magnetic field? Is this a long-term solution?
Okay, so this is actually the first step. There's actually two more steps to actually achieving what I'm trying to aim for. So the next step would actually start building an ozone layer. And in order to do that, the first approach that we would have to do is actually start introducing. Here's my silly slides. Actually start introducing cyanobacteria, for example. Oh shit, did I delete it? No. That's all right. But anyway, introducing certain groups of bacteria to try and extract that out. And this is probably the most difficult task for us to actually build that oxygen and release that oxygen and nitrogen, because we know that on Earth we have bacteria that's capable of doing this. But the problem that we face is if there's already life on Mars, do we want to be basically throwing bacteria onto the Martian soil? So these are concerns that need to be addressed. But if we were just to follow through with the process, there are bacteria and that can help to at least extract that oxygen out from the carbon dioxide that's being released, and try to at least start that process of introducing oxygen and building that ozone layer. Also, you'd have to change the regolith. So the regolith is high salt; it has perchlorates in it, and these perchlorates are unhealthy for human beings. So basically, if we are to try to introduce plant life, this will actually basically have these perchlorates in it, and if we consume it, it will actually compete with the iodine that we need for our thyroid and affect our hormones, because this is one of the main organs that are responsible for this. So this is something that we know is toxic for humans, but the cool thing is that we have actually found bacteria that are perchlorate reducing bacteria that can help at least help us introduce other bacteria that will fill the soil, and then we can introduce plant life slowly and try to get that ecosystem going. But this is not an easy task to achieve. I think we both face this. Not so much for me. It's challenge. Actually to build the atmosphere. But the problem is that we both have to try and introduce life to both planets at some point, so that we have an environment that is self-sustainable. And this task here is, for me, extremely important, building that biosphere, because that will help build the ozone layer. It would help extract the nitrogen locked up in the nitrates, and basically feed that into the atmosphere, so that we could build basically a breathable atmosphere, and that will protect us from high radiation, like from X-rays, UV radiation, and gamma rays. But the next part, yeah. And I guess the last thing is, I probably won't jump to the magnetic field yet, because that's going to take some explanation. But at least this would be the first step that I take to trying to address that problem. The other thing we could do is just fire asteroids into the planet, but I do want to try and sort of build in a different way, just to expose some of the different ideas that are available to us.
So, just to be clear, are you suggesting that rather than trying to establish a magnetic field to protect an atmosphere, we will just use mechanisms to just put enough atmosphere into the system to prevent it from being stripped away? Because there is a fear of long-term an atmosphere being stripped away absent a magnetic field.
It requires us to have a magnetic field, but I haven't gone into explaining how I'm going to build that.
Okay, but there is a plan for that. That's what I was asking. Okay. So Nixy, do you want to address that, and then perhaps we can move on to a second, or Robby? No, never mind. Go ahead.
My phone is doing the same thing again. I'm getting like poor signal, and so I'm not hearing your question. I've just gone back to my Wi-Fi, so I hope it comes back. Sorry about that.
Yeah, no, I was just asking if Nixy wanted to address the concerns about the magnetic field or the lack thereof, and how that might be used to protect the environment, or how it might not be, or whether it's not necessary. So, Nixy, if you want to go ahead and address that, and then if you want to rebut Robby, you can. Otherwise, we can move on to another topic after that, perhaps the question of magnetic fields.
So what I want to address is this is where the Martian magnetic field comes to play. Even though Venus has a weak magnetic field or no magnetic field as Mars, it's got more gravity to hold on to an atmosphere longer. Mars will lose its atmosphere faster, even if it has the same pressure. It has to have the magnetic field because Venus will lose their magnetic field or its atmosphere at a much slower rate because its gravitational field. Again, this is where Mars's weakest point is its gravitational well. It affects the atmosphere and its ability to lose the atmosphere, so the magnetic field is even more important there.
Yeah, I really want to address that because these are vital points that I think need to be explained here. So, secondly, there's two processes to atmospheric loss. One is through thermal processes, and the other is through non-thermal processes. So, the thermal process is basically related to the velocity of particles on the surface. As I heat it up, the distribution follows like a Maxwellian distribution, and on the higher leg of that distribution, you will have some particles that can exceed the escape velocity. So this is one factor that I need to cater for. But secondly, that doesn't contribute as much as the ionization of the non-thermal process, where that basically converts like the energy coming from like cosmic rays or anything that can ionize any of the outer atmosphere to exceed that escape velocity. So this is where the magnetic field is extremely important. And if you look at this diagram, it's probably hard to follow. But what you can see here is where Mars is located now, and then if we were to shift it to a temperature closer to Earth's, you can see these angled elements here. So you've got hydrogen, helium, all of these. This kind of like shows us where the escape velocity actually takes place for these elements. So all of the ones that are necessary for an atmosphere, they actually still sit in this range. So oxygen and nitrogen, when you shift Mars here, are still within the atmosphere, and all of them below are still within the atmosphere here. So you can see as the temperature increases, the escape velocity is increasing, which here. This is basically to illustrate that we can still have atmosphere, at least from the thermal process that stays there. Maybe you can.
Yeah, on that, I'm just curious. On that graph, does it say that Venus is only at like 350 Kelvin? Where is the
That's if
dot for
it's
Venus?
terraform. That's if it's terraform. So it's trying to pull it
okay.
back.
Okay.
Yes.
I'm like, that's not right.
Well, see, once you terraform it, just this graph, that Robby brought up brings the strong case of Venus, because once it's terraformed, look at the similarity between the Venus and Mars, or Venus and Earth. We're twins. So thanks for bringing up the slide that shows you once terraformed, it is almost identical.
I guess it's just sort of correlating that you have a similar escape velocity to Earth. But I guess but the next thing that I want to address, I guess, is actually protecting us from the ionizing radiation, which is actually the biggest contributor for depleting the atmosphere of Mars. And that would actually require us to build an artificial magnetosphere. Now, one thing I do want to address is that Venus has a magnetic field that is formed through its ionosphere. And this is important because as you start to decrease the density of the atmosphere and make it Earth-like, that's going to lose that protection from any external radiation. So, in fact, the important factor that I sort of want to bring up here is that Venus and Earth, they have different internal structures. So here you can see the image here. You've got a solid core for Venus, and obviously there's still research being done on this. But the key thing for Earth is that it has a liquid outer core, and that basically helps for the churning and basically the convective currents under the Earth's surface that helps generate the dynamo effect that we think generates a magnetic field. So we both face this problem of generating a magnetic field, and this is I think the advantage for Mars is that when the approach that I want to go about generating a magnetic field, there are two options. So we can go about it using like I guess a superconductor and using these solenoids to build like how do I explain that? It's pretty hard to explain. But basically, they would be current loops coming out of, like, if this is Mars here, you have like the radius of this coil, and it's coming out of the page, coming back into the page here, and we send a current.
Are you proposing we build a giant electromagnet the size of a planet?
So
Is that the solution? That's one of the solutions. Okay, I just want to make sure I'm understanding properly.
This does come with extreme risks, especially if you're working close to that environment. So this is something that I would absolutely not be for. And they tried to solve that problem by actually like breaking it up in smaller components, but it's still an issue here. But the problem is what you could do is expand like the basically radius of that loop. But the problem is the further away you go from the planet, the more you need to increase that intensity of the magnetic field, which is not so efficient. So what they suggest is actually going to the Lagrangian point 1 and putting like basically constructing a magnetic dipole there, so that the Mars has like a tail the magnetic field would have a tail that incorporates Mars. This comes with issues as well because obviously it's not that stable, and you'd have to have like stations out there to hold it in place. This is one solution, but this is technology that's way out there. But secondly, I think this is a better option.
Well, let me address the Venus magnetic pole that you brought up before you go to option 2. Do you remember that 90 atmospheres of CO2 that are buried at the now what I can do is not even build a magnetic field because I have 3 billion years worth of oxygen stored in the poles that I can slowly release the oxygen and bury the carbon over 1 billion years. So I don't need to build a magnetic field. I can let it get slowly ripped away and then slowly bring it back in because I still have it all aboard Venus. So my solution is not to build one. And if we eventually want to build one 500 million years from now because we get tired of releasing some of the oxygen buried in the core or in the poles, that's my solution.
Yeah, and I think that's one way you can go about it, but I definitely think that you should definitely put a magnetic field there, or at least keep a cell shade in front of you. Mainly because with that amount of radiation in, I don't know with the carbon how much that will actually, how safe that will be to keep that there, right? I think
because I'll have an ozone layer because I'm releasing oxygen. That will absorb it, it'll be lost, but I can replace it without having to go off-world.
What about cosmic rays and high-energy solar radiation? Higher energy than UV?
Because of the thicker atmosphere, it's going to be... Cosmic rays still hit the upper part of the Earth's atmosphere all the time.
But it's a magnetic field.
The Van Allen belts just hold the atmosphere in. They don't. It's not a cosmic ray shield. The sun shields us for most of that.
Isn't it the magnetic field that's protecting us from most of the solar winds that is depleting our atmosphere? Like the two issues that I see here. And
right. So the solar winds would deplete the atmosphere. I don't mind the depletion because I have billions of years of oxygen stored in the core or in the poles. So I can just continue to release more oxygen as it gets.
So I didn't mean to clear my throat to interrupt you. I just actually had to clear my throat. But I could be wrong, but I thought one of your solutions to the Venus atmosphere problem was to make the atmosphere less thick, so you would still run into radiation problems, would you not?
Right, but
Yeah.
then as not radiation problems, I'm not running into radiation problems because I have a thick enough atmosphere. I'm going to lose atmosphere to the solar winds, and I can just replace it with all these carbon and or all the oxygen stored at the poles.
Okay, Robby, if you want to go ahead and respond, all you.
Yeah, I guess just one last thing. I just think like to be storing carbon dioxide under the earth, I just see that as a huge risk factor. I mean, like, yeah, I guess you could go about it this way, but it would be something that I'd be opposed against because having that much there. But I guess what I do want to get to is the actual proposal for the magnetic field that I want to generate, which is completely different to this idea, because I think this idea requires too many resources and isn't as efficient as the actual magnetic field that I think is probably the better option for Mars, and that is actually using material from one of the moons, building basically. You have, I mean, this is getting super science fiction, so just be clear that this is something that would be something built in the distant future. But essentially, what you could do is basically use one of the moons and vaporize that material to eject it. So as it orbits, it will be ejecting material into its orbit, and it'll be tracing out. And so the key thing is that Phobos, one of the smaller moons, as you can see here, this orbits Mars in 7 hours, and basically, well, to be precise, 7.6 hours. And in doing so, you'll be releasing material that will become naturally ionized from exposure to the radiation. And what we would have to do is actually have some kind of like ISS stations, but in orbit around Mars, that could help to basically accelerate those electrons to form a current in this torus that we're hoping to achieve here. And in doing so, you would get a current going that would actually build a magnetic field. And the thing is, why we know this works is this technology that was developed here on Earth, but one of the moons between Jupiter and Io actually uses procedure differently. It actually ejects through volcanic eruptions into the atmosphere, and the magnetic field of Jupiter and the rotation of Io actually contribute to actually accelerating these ions and electrons, and this builds a magnetic field. So this is the same process that we're trying to achieve here, and it seems to utilize the least amount of resources. Resources, but it would require us to actually build a lot of stations to accelerate those ions and electrons. And there are certain things that you have to ensure that the electrons are actually have more kinetic energy than their thermal energy, and all of these. But this is more of the science that we don't need to get into. But the concept is basically what's important there. That it is
And we can
feasible.
always.
The biggest downside of this is that you would lose Phobos.
Yeah, so actually, that is a very sad.
We're going to
fact.
lose
But I mean,
Phobos in 100 million years, anyways.
I'll be
And I
long
do
gone by
love
then. Anyway, Nixy, do you want to
But
respond?
Yeah, and I think it's a good idea, and we could do that by capturing an asteroid around, because that's all Phobos is. It's a moon just because of its orbit. It would be easy enough to capture one around Venus and do something similar. But I also have all this carbon dioxide that I can take off world as needed. So it's really up to the Venetians to make that decision at that point in time. I have a different problem. I'm closer to the sun. I have more gravity. I'm going to lose atmosphere slower, and I have extra CO2 that I can slowly enter in the environment over the next billion years. So I don't have to do that because I have the replacement. And don't forget, ticking time bombs. The Earth has a ticking time bomb of methane at the bottom of the ocean, that if the oceans get too warm, methane would be released, and that is a huge time bomb. So to think that worlds don't have time bombs, you have to know what they are, and you have to monitor your world. And that's the important thing about the Earth that we're pointing out, is how fragile the Earth is and how we need to take care of it. If we're going to terraform one or both these worlds, we have to take care of our own.
I do have a question that popped up for Venus. How close are you projecting that you could get Venus to Earth's orbit using
We
asteroid
would,
impactors?
yeah, we only are going to move it 5 million miles further out, which gets it into the Goldilocks zone.
And that's what, like 70 million miles away or something like that? 71? Isn't Venus like
Well,
60 something?
yeah, we're only moving it 5 million miles more out, which will get it closer than Mars.
The only reason I
Can
ask
I
is
just
because
sort of,
one of the concerns is higher radiation because it's closer to the sun. And that's bad for
Yeah,
humans.
yeah, that's two things. Is I think we can't underplay how terrible that carbon dioxide is. That's not something that was like, oh yeah, we've got the same risk on Earth. I do really want to point that out because the amount of carbon dioxide there is like a far a bigger risk than what I think is being presented here. So I just want to make that
but
clear.
it is in the models, and I ran computer models, is that ice starts acting as an ocean and it starts regulating the atmosphere too, because you have these two cold bodies that are covered in dirt. Remember, we're not leaving them exposed to the surface, we're burying them. They're going to also help regulate the temperature, and then bringing an ocean on board. And we're not going to be able to populate the top or bottom of Venus, only a wide swath, which is more surface area than the entirety of Mars. Got to remember how small Mars is.
Yeah, and I guess the other thing is I just wanted to really make it clear that when we're talking about moving planets, like this is extremely in the distant future. I mean, I think like when this, at least with the magnetic field, this is probably the most furthest of the technology that we need to utilize, and having space stations to hold this together. But everything else that I see with Mars is actually technology that we know works well here on Earth, and it would just be difficult to actually achieve that because we have problems with getting to Mars. But yeah, I guess like to shift the planet from outside of the habitable zone to the
It's
habitable
just
zone.
impacts, baby. It's just impacts. And this is just Newtonian physics. We don't even have to get into relativity for this. This is just Newtonian physics, and all those rockets that you need to get all your equipment to Mars, I'm using to deflect asteroids with. So I'm using the same technology you are.
Nixy, I do have a question. You ran some computation, so I just wonder if you have this number. What kind of total delta V are we talking about as far, or sorry, not total delta V, like I guess what I'm asking is multiply the size of the rocket by the how much delta V you can give to an asteroid. I'm basically asking for a measure. You could use a bunch of tiny rockets, but are we talking 1,000,000 tiny rockets to move these asteroids to get 10,000 to collide, or are we talking 100 tiny rockets? Because the scale is certainly important here.
Yeah, and I was using 3 times the payload of Starship, and it would take 4 impacts to move most of these 2 kilometer asteroids to in orbit. So, and that is 2,000 times the kinetic energy that DART had. You got to remember, DART was a scientific mission to show us that. I'm taking these, and I'm doing it over timescales of 100,000 years to get the atmosphere where it needs to be. This is not an overnight project, but it's the lowest risk because at the end of the day, we're cleaning up the environment while we're doing it. So rather than just push these asteroids out towards Mars or into the sun, let's push them into Venus and solve 2 problems at once. Let's give ourselves the second home, and let's clear the Earth's orbit and Venus's orbits of these impactors, potential impactors, these near Earth objects.
Yeah, and I think like with at least with DART, I think it was 2 millimeters. I can't remember.
Yeah, and it was only
Just pick them.
it was only what, 300 pounds, that payload. It was very little.
Yeah. I guess what I do want to say is I want to save Phobos, and I want to let you know that it has enough material for 10 to the 11 years. So the sun will destroy will destroy our solar system far before Phobos is gone. So we will still have it there because the material that's been ejected is just going to deplete on a slow scale. But the important thing is that during its orbit, it replenishes that basically. That belt or the torus that we're trying to form to actually generate this magnetic field. So there's still hope for Phobos. I just want to make that clear.
Yeah, but Phobos, you're going
That's
to have to
delightful.
stabilize its orbit because it's going to be gone in 100 million years or less.
So I do have an important question. What timescales, this is for both of you, what timescales are these kinds of suggested methods of terraforming Venus or Mars on? With current technology, cost, don't worry about political will because we know there's no political will to do any of this anyway. What kind of timescales are we talking, and how long could such communities thrive on those planets?
So Venus is long term. It's 100,000 years to get it to the point where we can start introducing life. But the advantage is it's billions of years of stability. We don't have the biological issues that Robby may run into. We don't know, but just looking at the physics of humanity and not having a gravitational field is quite big. Second, it's closer. It makes passes by me, and people can theoretically very easily move between the worlds, so we don't have to have evolution happening. So we have a species of Martians and a species of Earthlings. We can have two species, but we're on the order of about 100,000 years.
Okay, and
Yeah.
Robby?
So with us, it's within a few centuries. So the short scale the short scale fixing for this is actually pretty in the literature. It's saying that it can scale from this, but I think the part that will take long is actually building the biosphere and making it actually habitable for human beings. So that can take anywhere between a few centuries to thousands of years, because that's probably the biggest problem that we face, even for both planets. So that's where the timescale is trying to introduce a biosphere, so that we have life that can actually thrive on there and that we could live on the surface. I mean, we could go there pretty soon if we were to just like build firmaments, just to say we could build a little firmament, and that could at least provide us with safety to at least go there and stand on the surface and try to do some research on Mars. But at this point,
Don't give them any ideas. Don't give them any ideas, Robby.
That was Jorge's idea, Pumpkin. That was Jorge's idea. Robby, Pumpkin.
I've got a pumpkin.
So, just to summarize, just to make sure I'm understanding everybody's positions properly. So it sounds like it will take Venus 100,000 years to even get to the point where it's habitable by any type of life, or to get to the point where it's suitable for human life in a comfortable way.
Suitable for taking the long-term approach, not slamming too many things at once and getting it to that point. 100,000 years in most simulations, and then you have an equatorial band that's on there that is larger than Mars, that is the average temperature of 20 degrees centigrade.
Okay, so
and the days will be 8 days. It will be 8 Earth days, because as we're hitting it, we're moving it out and spinning it up, and you do have to spin it up so you can get the cooling at night.
So so this is a question for both of you. I know that there are discussions in both cases, both on Mars in the form of either underground communities or firmaments, and in Venus with some sort of sky communities, which is the coolest thing in the world, by the way. Like it's out of this world even. What are the thoughts of what are your guys' thoughts regarding building communities slowly while terraforming? Is that possible given the means by which you are suggesting that you terraform these planets?
No, Venus would not, because of the collisions that are going to take place. But I'm adding the benefit of getting rid of Earth's things that could end civilizations on Earth by getting rid of the asteroids that are a nuisance to the Earth.
Robby?
Yeah, so that would actually be part of the whole terraforming process. We would actually build infrastructure there as a stepping stone, because you would have to apply that at least to start like mining the materials, because we have to do in situ, infrastructure there. So I guess that would be something that would be implemented there. And it's not to forget that we don't require oxygen for all species, so we can actually still slowly start introducing biological life over there in plants that could thrive in those conditions. Bacteria obviously being more suitable for extreme environments. So that would be something that we would try to utilize and have that as a tool to help us. And actually being there and looking at like studying the Martian surface will actually aid us and give us more data to figure out how we can go about this procedure. Because to have an ecosystem like Earth, and this goes to show how important and how wonderful our world is that this has taken like billions of years to build the atmosphere that has enabled us to thrive on this planet. And so for us to try and replicate it on another planet is not an easy feat. And to try and find that ecosystem and that balance that would enable us to stand on the surface without any technology, I think is a difficult task. And I don't know if we'll ever be able to achieve it, but it's something that I think is within our means to at least explore and look at the ideas. But obviously, home's where it's at.
Now, Nixy, you laughed when Robby said hundreds or maybe thousands of years for terraforming Mars. Do you want to talk more on that point before? Because, by the way, we are reaching the 90-minute mark, and then we're going to open it up for questions. There's a list of questions that'll go over. But do you want to address that before we maybe come to concluding statements?
Yeah, I think thinking that we could do it in a century or 1,000 years with the factory approach, the amount of materials that just getting at the factories, finding the resources on Mars, you're looking at centuries. I believe you can do it faster than Earth. I definitely, or than Venus because of the approaches, but I think you're on the order of 10,000 years before you're really going to get there. And I know that I've read those same papers, but they're also assuming some huge assumptions. And I think you're looking at a much longer time frame than 1,000 years. I don't think that's really reasonable.
Well, I think given the assumptions that they've made in the paper, I think it is a reasonable calculation and what they've done. So if you can generate that amount of power, you should be able to at least initiate that that initial greenhouse effect in 40 years, and that will start to melt. And this second mechanism with the greenhouse effect melting the poles, that's why in the calculations they range from like a few centuries to 1,000 years, but this is also inclusive of a breathing atmosphere. If you're talking about just like getting it to like a biosphere that can cater for life, I would push it to the higher end as well. But as for like if we're on the optimistic end, I don't see how that couldn't be done in this way. But the range is given there, and so I think that's important that we look at the optimistic end and also the opposite end, which could take, as they pointed out, thousands of years.
So do we want to do like closing arguments?
I was just
Q&A?
about to ask. Let's do 2.5 minutes each for closing arguments, and then we'll do Q&A. Yeah. So I guess Robby started, so Nixy should get the final words, I think. So Robby, do you want to start with your closing statement?
Did I start?
Is that fair? Is that how it's usually done? The person who's...
I'm good either way.
Did I start? I thought Nixy started.
Well, didn't you give the first? No, you're right. Nixy did start. Well, whoever wants to go first, feel free.
You go first, Nixy.
Okay. So in closing arguments, I think the biggest advantage Venus has over Mars is we're cleaning up our celestial neighborhood. We don't want to, Earth is our haven. And until we have another world or two worlds, we have to protect the Earth. We have to protect the Earth from all kinds of things. And a giant impact like Apophis, may take out a continent for us. So to fling them at Venus with the long-term approach of making Venus our future home solves two birds with one stone, and we have the technology to start doing that today. We start with smaller impactors, and then as our technology gets better, we can do larger and larger ones measuring the impact. As opposed to going to Mars, where we may have biological issues because we're looking at 40% the gravity. I'm not going to say we definitely know this, but common sense, when we look at the gravitational issues, you know you're going to have bone density issues, and you know you're going to have much less muscle mass. And humans have lived for 250 million years or 25 million years as bipeds in 100% gravity. It's common sense, or I should say it's logical, that there's going to be less issues moving to 90% the gravity, and we can clean up the environment. Should we look at Mars? Yes. Should we build moon bases to help us find these asteroids that we can slam in there? And that will give us the long-term answers of whether Mars is suitable or not based off human biology. In closing thoughts, Venus solves two birds with one stone, and it prevents our Earth from being impacted in the future with near-Earth asteroids.
Robby?
Yeah, nice. Yeah, I think like overall, I do see Mars as a stronger candidate for terraforming, just because of the amount of energy and resources that would be required to terraform Venus. Not to say it's impossible. I would, if we were to go down this route and look at terraforming planets, I think both projects that we are probably capable of achieving in the distant future. Right now, I don't think we have the technology to achieve these anytime soon, but it is in development, and I think in the future it is a possibility. I think what I really want to address is that, for both planets, I do see them as viable options for potential planets where humans could possibly go to. But I think the important thing is to through like this discussion, I just hope that we've exposed or shown how difficult it is to pull these tasks of terraforming off, and that all of that effort that would consume so much resources from Earth, and everything that we need to do to achieve this, and energy. So for me, at least as a closing statement, I think we should really look at trying to look after our home here on Earth. And just, I hope through that we've shown at least how precious the Earth is, because it's perfectly, well, I wouldn't say it's not designed, but
I'm about to tell you about a puddle if you say that.
Okay, Douglas Adams, he gets a pumpkin for design.
But I think that's the thing that we recognize. Like it has gone through an evolution that is able to environment so that we can thrive in all of the living species on Earth. So I think we live in a unique place in the universe, and I think it's the only, I guess, like Carl Sagan said, it's the only home we've got. And I think from that, we should really look at trying to look after here at home, and just recognize the difficulties of trying to shift to another planet. But yeah, blah, blah. Thank you.
Excellent. So before we move on to questions, I'm just putting something together. I'm going to make a 5-minute poll that I'll run during the Q&A, just asking the audience who they think did better, or which they're more in favor of, all of these lovely things. So go ahead and make sure that you vote in the poll. I want to see what the 400 plus people in here think about the discussion that we've had, whether you think Venus or Mars is a better place to terraform, or will be a better long-term goal, if you will. So the poll is there. So there is a Google Doc that has been compiled. I would ask that nobody add more things to it. I'm going to go through the questions on the Google Doc, and then I'm going to take questions from the comments. There are some people, I think Mara actually has a question in particular, so I might bring Mara up to ask a question about chemistry. That might be too long to express. So first question is, can Mars hold an atmosphere? I think this is probably to you, Robby.
So in its current state, no. It doesn't have a magnetic field to protect it, but it's got an atmosphere, and it is depleting. But if you're talking about like an atmosphere that is similar to Earth's, if we do terraform it, it wouldn't be able to hold it without a magnetic field. Yeah, maybe I hope I answered that correct. Well, in a way that's comprehensible.
So there is a question that says planets without water. Not quite sure what that means. Presumably neither of them have a whole lot of water on them. So how would you address that?
Sorry, Mars does have enough water on it, actually, and it's got enough water that if it were to melt, you would actually start filling up the rivers and have oceans and lakes forming. But that's something I didn't address, is that Venus has an issue with that.
Yeah, the
Nixy,
one
go ahead.
comment. Yeah, the one comment 2014 UN 271 solves two problems. It puts the final layer of dust on there, and it delivers more water than Venus has. Or not,
Okay.
than Mars has.
So
I'm getting confused. Too many planets.
So this next question is for Robby. It just says life on Mars. I interpret it to mean, what if there's already life on Mars? Would it be ethical to terraform it?
Yeah, this would be something that we probably wouldn't want to intervene with. Like, for the sake of this conversation, we were talking about like throwing like life at Mars, but in reality, like there's a lot of things that we have to, at least the ethical approach about this would be that we probably have to pull back from trying to terraform a planet if there is life. That would be my opinion. But obviously, some people wouldn't care too much about life. But in my opinion, I would probably try to pull back.
Yeah,
So
and
there's
if we find life on Mars, Mars is a no-go, and I think we'll find life on Mars.
The next question is perhaps for Nixy, perhaps for Mars, or perhaps for Robby. The question is, Venus is closer to the sun, so it has more resources. Is that the case? Does that tip the argument in favor of Venus, or does it make it too dangerous because the sun's too bright, too hot? Go ahead. Nixy, go ahead.
From a solar power standpoint, I'm going to get much more use out of a solar panel than Robby is. They're going to be 1/4 the size for the same amount of power. Second, because the orbit is faster, we have more approach windows when it's easier to get from Mars to Earth and vice versa. Mars also has issues with it not having a lot of metallics in its crust for mining, but it's close to the asteroid field to do that, where I have a lot of metallics that have been spotted right on the surface. So yeah, there's far more minerals for use on Venus.
There's another question. I'm not sure who it's for. Oh, Robby, did you want to address that? The
No,
Venus being
no.
closer so it has more solar power? No? Okay.
Yeah.
Okay. I'm not sure what this next question is. It just says, why not put something reflective in the atmosphere? Not sure who it's for or why it's there, but anybody want to address that?
That's for Venus, and that's what I'm doing because I need to solve two problems. I need to speed it up so we have longer days. I need at least a 10-day day. Venus day is 400. I want to get to at least 10 days so you have the heating cooling cycle. That alone will solve a lot of the heat issues. The second thing, I need to move it away. So by putting the dust in the atmosphere, it is going to allow Venus to cool.
Okay, excellent. The next question is, do either planets have a similar spin as Earth? I can answer that. Venus, no. Mars, yes. It's a problem for Venus, less of a problem for Mars. If we go to Venus, can we have more birthday parties in a year? Anybody want to address that?
Yes, you will live the same length, but you will have less birthdays or more birthdays. You will have more birthdays. Right. And Venus, in Mars, just think, when you hit the ripe old age of 40, you're old on Mars.
That's true.
You'll live to 130 on Venus.
So for what it's worth, I don't know how this happened. The poll just ended. 46.81% for Mars, 46.81% for Venus. A dead tie. So congrats, everybody. We haven't made a decision. The next question, isn't Venus too far? That's presumably for Nixy. Perhaps Robby can address it and use it as a jumping off point.
Venus is too far? Too close?
No.
Yeah, I think that's probably what they meant. Probably isn't Venus. Well, maybe they meant too far from Earth.
Maybe too far from the habitable zone.
It's
Well,
very.
that's what the
It's on
question
the
said.
edge. Yeah, and,
So-
there's debate
fine.
whether it's in the habitable zone or not. I wasn't willing to debate that. I'll take the L on that because I want to move it anyways. With the impacts, I will be able to move it. I think the biggest advantage to the Venus approach is we're benefiting Earth by doing it. We never benefit Earth by doing Mars.
So I guess just one question I have to follow that. Like, if we are moving planets like Venus and we're trying to pull it into the habitable zone, we'll be pulling it closer to Earth. And in doing so, like...
That was a question somebody brought up. Could that...
Oh,
it's not on the list. I was going to ask it after we finished the list. Is that a problem? Could it disrupt the Earth's orbit?
I ran a billion-year simulation moving at 5 million miles and 15, because this is who I am, and within 15 million miles of Earth. If it gets within 20 million miles of Earth, it will start interacting. As long as we only move Venus 10 million miles close out away from the sun, we're good. And we both have a problem in a billion years. These are billion-year solutions because in a billion years, the sun is going to start heating up and both our worlds are going to be toast.
And the original one.
Yeah.
That'll also be... So there's another question, which is interesting. I think it's a little bit more short-term. I'm not sure how relevant it is for the questions of terraforming. But what is the delta V to get to Mars's surface or off of Mars's surface compared to getting to Venus's clouds? How do those compare?
It's about 80% the energy to go to Venus than it is Mars.
And presumably it's easier to slow down to reach the surface because it has such a thick atmosphere, if that was the goal. But that's not the goal, so it's not super relevant to the conversation. Right, so there was a question. The safety issues for travel was mentioned by Robby. Is that not also true for travel to Venus?
Yes.
Okay. With respect to slamming planets, what's the impact of such move to the rest of the solar system? What's the impact of such a move to the rest of the solar system? Will it disrupt any orbits? I think
No.
probably not.
It won't disrupt, but the advantage of getting rid of the near-Earth asteroids means we don't have another, instead of the dinosaurs, it's humans. So this is the biggest benefit of Venus.
There's a question about reaching the habitable zone, but we've covered that. How long is the planet Venus? Okay, we've covered that. Why would it be possible? Would it be possible? Would it be possible to begin creating a magnetosphere on Venus as it's moved?
Yeah, because you can just do the same thing Robby researched and put one of these asteroids in orbit, because that's all Phobos is, and release the material.
Now, a question for both of you. This is from Mara, I think. Why isn't the actual chemistry of terraforming being addressed by either proposal? Well, it's because you don't. It's because you have an astronomer and a physicist here, and not a chemist. That's why. And it actually says something about the way that you guys are proposing approaches, because Nixy is, of course, an astronomer. Just slam asteroids into it. Robby is like, well, maybe we can build a ring of charged particles to give a magnetic sphere, a magnetic field. But yeah, so what are the questions of chemistry? What actually needs to be done? Are there any serious issues regarding the chemistry of those planets and the what's available, what kind of elements they have present?
The Earth's crust is more similar to Venus in all the studies. Mars does have the stuff, and it's really going to require boots on the ground when you talk about chemistry a little more. And yeah, I mean, I'm not a chemist. I can teach chemistry, but I hate chemistry.
yeah. I guess
Robby, do you want to address that?
That's why I love chemists, that we have them.
Yeah, I guess like when it comes to like chemistry, this is by no means my field of expertise. But I know, like at least for all of the resources to generate an atmosphere, that's abundant there. And then also the same with like trying to make the soil or the regolith suitable for life. Like all of the resources for us to survive out there on Mars. Obviously, these are estimations, and they've tried to constrain these values, so we can't be certain about everything we're talking about because making observations and sort of collecting data from what they can with the rovers. But with the chemistry, like there's, I guess, like amongst this whole thing, there are a variety of fields that we had to explore here, from biology to chemistry, astronomy, physics, blah blah, computer science to control all of these like robots and stuff. But these are things that I don't speak too much on because I'm not really well versed in these areas.
So that is the end of the listed questions. So what I'm going to do is I'm going to scan comments for questions that people might have. If they're interesting, I'll ask them to the panel. So feel free to shoot your comments in. We have about another 15 minutes or so. I figure half an hour for Q&A is probably good, and we can end at 9. Yeah, go ahead.
Haley's calling me a venophobic.
I mean, aren't you though?
Yeah, well, Haley's always right, so we're good. Haley's vote should have counted for 2 because I couldn't vote, but Robby could because I'm one of your admins, so we won by a millionth of a percent.
So here's a question, which is interesting, and it's proposed by Mario. What tech can we use to terraform, or what tech used to terraform either Venus or Mars can we also use to preserve Earth? Because Earth should be our first priority, of course. And so the question is if we're going to develop technology to terraform it, it would be better to develop technology that can also be used to preserve Earth simultaneously.
So I'm using my proposal, and then I'll let Robby go. My proposal is to get rid of asteroids that could re-terraform Earth while we're on it, or unterraform Earth and slam them into Venus. Robby, your turn.
I was going to say, yeah, the technology we've got is to slamming asteroids into Earth that will solve all our problems. No, but on a serious note, I think like a lot of these technologies, there's lots of spin-off technology from like doing these missions to Mars that could be utilized here on Earth. So, for example, these 3D printer homes. They're also designing these on Earth, so they have homes that they want to utilize these structures that I showed you. Maybe I can go to that slide in environments here. So this is just the Martian technology, but there's also, like, if you go to the website on the link there, you'll also see that they've developed this technology on Earth as well. So there's some on that way, but in terms of terraforming, like. Like if we find ourselves, for example, having to deal with like high concentrations of perchlorates on Earth, we could start utilizing this studies that we've done where the bacteria are able to reduce those perchlorates in soil that was found in the dry areas on Earth, and I think in the desert in Chile. And so this was one of the studies that we've done here on Earth that would be utilized to try and terraform the regolith of Mars. So through this, it gives us insight into some procedures we can do about combating things that apply to even with climate change, how we could reduce that and some of these techniques. So yeah, I think there are some things out there, but yeah, I guess we have to. Yeah, I'm not an expert engineer, so I don't know all the engineering behind the technology and things like that.
All right, so another question. This is for Robby. I don't know if you know the answer. Can we bioengineer lichen for coating the Martian polar caps?
That's a possibility, yeah. I should have mentioned that. That was something that you would introduce as well.
Another question. Wouldn't we already be traveling to other planetary systems by the time Venus is terraformed? Wouldn't we develop faster methods by the time it's done? What makes spending 100,000 years terraforming Venus more worthwhile than just finding a better planet that's already Earth-like somewhere far away?
Well, you're talking about interstellar travel, and to say we're going to be able to do that and even find those worlds, and then we may have to terraform them as well. The benefit of doing Venus is we're getting to clear the orbital debris around Earth that can end civilizations or mankind itself. So I think it's worth doing because it gives us a second home here that we know is here, and it helps us clear the orbital debris.
Excellent, excellent. Question for both of you, if you know the answer. What is the probability of ruining either planet?
Venus very high. Mars.
Well, you can't ruin something you can't already live on. Could we make it worse on Venus? Could we make it worse on Mars? Yeah, most definitely. Robby could release all the carbon dioxide and not hold on to it and then have to ship it from Venus. So, there is that.
Yeah, I would say, yeah, there is risk. I mean, like, for example, I've been on there, and if we don't recognize or find life on there, and then we just introduce all of this life from Earth, like the consequences of that, like how destructive that would be to what's already there, I think, is an issue that needs to be addressed. I think we could definitely screw it up by, injecting all these PFCs into the atmosphere and just spiral out of control. But I think, like, yeah, I just the slamming of asteroids into a planet, I just see that as it's funny.
So
I'm an astronomer. We see it all the time.
So that addresses the other question. This is a question from me. Should we just terraform Venus instead because Elon Musk wants to terraform Mars and we should just do the opposite of whatever he says?
That would have been a brilliant argument.
I mean, I'm not biased, but
I'm destroyed now. I lost.
Everyone, I want to thank everybody for coming in. If you're a follower of mine, follow Blitz, follow Robby Mars. Even though Mars lost by a
Hold on, we're not
technicality.
done yet. So here's a question to both of you. Oh, go ahead.
No, I just want to make sure everybody follows you. Thank you, Blitz, for holding this. Robby, it's been a pleasure.
Honestly, this is very fun, not having to ramble for an hour and a half and just listen, so that's fun. Right, question for both of you. Why not terraform the moon first?
Moon ain't big enough.
Okay.
Yeah. At least, like, with the definition we're working with, I think we could set up base there, and that's, like with Artemis missions, they're probably looking at using this technology that's actually on my screen to build up a little bit of infrastructure there, and they're going to put, I think it's the Lunar Gateway in orbit to make it easier accessible. So I don't know about terraforming it, but at least you could go on there. That's a possibility, and that's going to leverage as a stepping stone for Mars, hopefully. From what I read,
it's a stepping stone to Venus because we can build rockets there that we can clear the orbital debris, and that's I mean, as an astronomer, my number one thing are minor planets and near Earth asteroids. I can't emphasize that one asteroid could end civilization.
Yeah. But I mean, this is something that, like, Dark Mission and all of that are developing to provide that protection. That's actually the priority of those missions, right? So if we do have something, like, we could find it, detect it early enough, impact it, and then try to shift its trajectory so that it misses Earth. But I think that's why we're trying to look at multiple different techniques, because we don't know, like, if impacting will actually, because there's a lot of ejecta that comes from impacting. And so that's how they sort of change the trajectory. So there's multiple techniques that are being developed, but at least we're having some kind of protection mechanism through this to help us be safe here on Earth.
A question for Nixy. Do all Venusians have to grow mullets? If so, that might be a point in Mars's favor.
Yeah, I like that.
Business in the front, party in the back. So this was from Mitch. Was it interesting investigating the biological effects, especially considering that neither of you are biologists?
Yeah, actually, I thoroughly enjoyed that, and I learnt a lot, at least about the membrane, the extracellular matrix, and how vulnerable like these cells are in like to gravitational pull, and how sensitive they are. And so, like learning through how like even like conception occurs, and how like cell division uh, is occurring, and seeing how that whole procedure works. Like for me, that was a whole learning process, which I found extremely exciting, and interesting and fascinating. And then looking how sensitive they are, like realizing how lucky we are to be on Earth. Like biological systems are freaking awesome.
And for me, I really didn't think that there were going to be as many issues with Mars. You know, I would love for us to be able to live on Mars, but the difficulties of the low gravity environment on biology, how different it is, and it would probably cause speciation of humans that lived on Mars would probably speciate away from ones that live on Earth.
I'm
Yeah, I
curious,
think.
is that a bad thing?
I don't know. It's a thing.
I mean, the thing is that you know, when you're subject to different environments, like even on Earth, we notice that there are human beings that can reach higher altitudes. The Sherpas that climb up Mount Everest, they don't require oxygen, and so we have like people like these subtle differences between like the human race. And I think when you are subject to like 90% gravity or to 40% gravity, I think there's going to be a diverse of species that will emerge. But I think that's not a bad thing personally. I think, and if you are to like travel back and forth, if we become interplanetary species, maybe we have to cater for like the different. If we do want to still, hopefully we don't turn to war or, you know, war of the planets. But if we do want to continue that, we'll just have to develop technology. And like, given the thousands and thousands of years it's going to take to terraform Venus, this technology will be well developed for us.
Well, you better do it fast because there are enough asteroids near Earth that we need to do that. And whether we slam them into Venus or not, we need to take care of our local neighborhood. And
Yeah, you got to pick up
Yeah.
the trash. Question. I think I know the answer to this, but I'll let you guys answer. Can we make a planet with asteroids from the belt?
no, there's not enough.
Is that like
Yeah,
the
they have
moon
the
side?
mass of like Mars or something, or like half of Mars.
Less than Mars.
Yeah, and they're also really
Something.
far apart.
The other proposal I looked at, and it was on the term of like 20 million years to do, is to pull Mercury out of its orbit and slam it into Venus. And you would end up with a moon. You would end up with a moon around Venus.
Now that would give it a molten core, which might give it a magnetic field.
It would give it a magnetic field, a stabilizing moon, and but it's a very long-term thing. The But there's no body big enough in the solar system to help Mars with its gravity issue. If we live on the moon, and I would propose we live on the moon for multiple generations to find out what low gravity does before you start terraforming Mars. And if we find we don't have biological solutions, you know, a twin Earth would happen if you slam Mercury into Venus.
That's an option, I guess.
But all these are humans working together for tens of thousands or hundreds of thousands of years to do these projects. And these projects are for our children's children's. And we need to take care of the planet we're on because we can't terraform either of the worlds overnight.
So I do have an objection to the slamming thing. You remember how mad people were about giving up Pluto? They'd have to learn that there's only 7 planets then. Nobody wants that. And the first
But they get a new moon. But we get a new
Nobody
moon.
remembers the moons? Nobody remembers the moons?
Yeah, I think like when you're talking about slamming planets and these huge bodies into other planets, it's pretty funny. It's pretty out there. But I mean, in the future, I know that like it's something that a few scientists are talking about, but to me, it's just so way out there at this point. But I don't see Mars as being like a bad candidate, even with the gravity. I mean, like, yeah, it might pose us some issues, but I definitely see potential for Mars, and it is the closest planet to Earth, and would require the least amount of effort to terraform it. And so I think as one of as that being a major factor um, of the process, I think this is what makes it a stronger candidate. And it's not just me. I think there's large consensus amongst the scientific field, especially when you go through the literature outlining like why it's uh, the stronger candidate at this point. Because when you're talking about moving planets and asteroids, that's a difficult feat to achieve. It's not to say it's impossible, but I think it's technology that needs further and further development, and is a bit further into the future, but nonetheless something that we should be thinking about. But at least thinking about it, it's providing us with mechanisms to protect us from impacting asteroids to Earth. So it's a positive on that end.
Right. We only have a few minutes, so I do want to get to these 2 more questions because they're quite good. Um, why terraform at all? Why not just make large scale habitats, either on Venus or on Mars or in space or around asteroids?
Um, I think that's the best solution, but Robbie and I started this discussion on Haley's channel, and it was about terraforming. But I think
Okay, that's fair.
colonization in mini firmaments, as Jorge calls them, is a better way to colonize planets and moons.
Robby, you want to take that?
Yeah, no, that's the thing is that was a discussion. Actually, it came in with Hayley throwing Dad, and then she called in Nixy, and then we had this discussion, and so this is what led to this whole debate. But
I see.
but I think overall, yeah, I think short term, like Mars is by far like at least trying to get there at this point because of the atmosphere of Venus. That's just too far. I know they've proposed like these sky-based civilizations
Which are
because of
so
like
cool.
yeah, and that's a possibility, but I think that is probably not as easy as going to Mars, given at least it seems to be the trajectory of all of the like large agencies like NASA that are focusing on Mars at the moment because it seems to be a little easier.
What
My
about
only
Jupiter's more? Oh, go ahead. Sorry.
Yeah, the only concern I have with Martian or moon domes is the flat dome societies that will be created within it.
They'll be and they'll be right because they'll be able to see the firmament. They could just walk up to the ice wall or whatever. Right. Question: why not Jupiter's moons or Saturn's moons? The ones that might have oceans, for example.
Like Titan or something.
Yeah,
Yeah,
Titan
so
or
like,
Europa, Enceladus. These guys.
no. Europa, if you're a dolphin, I think it would be brilliant. But the problem is humans living in water all the time. That's the only problem. And you say, oh, I want to put a colony on top of Europa. Jupiter's magnetic field would sterilize you instantly, and in about 20 minutes, that would be the end of you because of the magnetic fields. So I think the moons are great to find life under oceans, but I don't think you're going to get surface life in those moons.
Robbie, do you want to address that?
Yeah, yeah, I think that's the answer. Good.
Okay.
Yeah.
Well, that was the end of the questions. I think I got you guys to answer the question, the chemistry questions, namely that you don't know much about chemistry. But Mara, if you did want to come up and ask a question, feel free to do so, and then we'll end it there. I don't know.
I guess one thing I do want to say is like to all of my friends that did come in and sort of was discussing some of these topics, providing like scientific resources outside of my field. Like I really appreciate that. So that was awesome that people did that. You know who you are. I can't list all the names because there were a few people that were providing resources for me to read through. Nixy being one of them as well. And so yeah, it was a cool thing for me, a cool experience, and something far outside of my field of research, but something still interesting and fascinating to learn about. So yeah, thanks to everybody that did contribute and for the gifts. And yeah.
So Mara, you have some chemistry questions.
Yes. I want to start by saying that I find this fascinating exercise. It's just super fun. It's been amazing just to hear everyone here. But I think the assumptions that this is only a problem of physics are a little bit, off on the left field. I find that the chemistry of Venus is so and is such an antagonistic aspect to not be able to tackle, right? So briefly, there are about 10 miles of supercritical CO2 floating at about 2 miles above the surface. Cooling it will yield about 100 feet deep sea of liquid CO2 all over the surface of Venus. So if you cool hold on. Just 1 second. So if you cool it, it becomes it can be frozen, right? So the question is, how to ensure that all of the CO2 at the equator can actually move in the precise fashion as it's dry ice onto those pole caps and not sublimate and come back as CO2, given that you've deflated the pressure of those 93 atmospheres to something under 73 atmospheres, so it's no longer supercritical. In other words, you would end up with an entire layer of dry ice that it's about, if I recall correctly, the calculation, about 30 feet deep across all over the entire planet. So how do you control that?
So the way the simulations, and I can share the simulations with you, it's not one impact, it's multiple impacts. And each impact is going to allow the dry ice to reheat on the equator and freeze at the pole. And then you do another impact, and that's going to take that carbon dioxide in the equator and freeze it to the pole. And you have to do it with multiple impacts. I thought I could do it with 1 or 2 impacts. It takes anywhere from 4 to 8 impacts so that you can move the carbon dioxide. Because remember, what is also happening is the pressure keeps going down, so the dry ice resublimates.
Right. So it is, just so people understand, dry ice sublimates at room temperature. So it's 26 degrees Celsius at 1 atmosphere. So if you increase that pressure, it won't sublimate. It'll stay as ice. But if you increase the pressure, it will liquefy, right? So if you keep the temperature low and you increase the pressure, it will remain hard. But as soon as that temperature increases, it'll sublimate. So it's a very delicate balance. That was my concern: how to control the conditions in that, I want to call it, in that environment, right? So that balance is not broken. But then the second question is, someone asked, I don't know if it was Blitz or if it was Nixy, about discovering materials in Mars. So this is not a question. This is actually an answer. So we know where the mineral deposits that are necessary to manufacture not just but actually steel carbon fibers, create the necessary chemicals to produce controlled reactions exist in Mars. The red dust is actually iron. It's iron oxide. So we can use that iron to create more of the product. So it becomes a surface mining operation. Do we need humans? Maybe people, but we've sent, robots, and they've been out there for the last 30 years. So I think we have the technology, the capability, not the funding, not now, but the capability to control that, remotely. So these are surface mines, and we would be mining nitrates, we'd be mining for certain other elements. There's ice, so we can resolve the question of, hydrogen, oxygen. There are perchlorides, which is an amazing oxidizer. So we have the ability to produce not just the bare minimum, but we can actually artificially inflate the atmosphere from within the substrate of Mars surface. We're talking about maybe 15 feet deep. We've seen what we can do in Africa. We've seen what we can do in South America. We've seen what we can do in the central plains of Asia. We are a destructive species. I don't think it's going to be difficult for us to just erase the top 10 feet of Mars surface and just freaking mine that.
That's so pessimistic.
You know what I mean? So I don't think it's not viable. I think it's actually feasible, but the question about technologies and how we use them, I find that reflection, and it makes us think, if we have the capability of terraforming something else, why are we terraforming Earth? Terraforming Earth is actually destroying the planet,
This was the focus
Yeah.
of the
and
end.
we don't stop.
Yeah.
I think we
That's
can all
why
agree with
you
that.
heard so many times Robbie and I talking about we got to take care of Earth because neither of these are quick solutions. And that's why I like terraforming Venus, because we can clear the debris away from Earth so we don't have a giant impact and we can protect it for future generations.
Right. So one last thing, and I'll shut up. This is not science fiction. This is something the U.S. Navy and I believe the Department of Defense of Sweden have tested. So there's something called perfluorocarbons, and they can actually they can actually capture a lot of oxygen. So basically, what happens is there's a fluid that you can breathe that contains sufficient oxygen that you actually don't need gills. There is this is sci-fi, but there's an idea of inflating Mars's atmosphere with dry ice. And then since the same products, the same chemicals are in there, those infamous CFCs that Robby and PFCs that Robby was talking about, and saturate the lower layer with perfluorocarbons that are rich in oxygen. And as these reactions take place, there'll be an ocean of PFCs. Those humans that speciate would be breathing this fluid. So you don't really need a dry atmosphere. It would be an ocean of a fluid that we humans would be able to breathe in. I was reading about this last night and it blew my mind. I'm like, wow.
Yeah, I've read about
So
this
that is
too. It's fascinating and also terrifying. Just the idea. If you're born breathing liquid, that would be fine, but the first humans to do it would have a really bad time. Right. So we are over
Yep.
time. So I think that this is just about a good place to end it. Any last words from anybody? Thank you for coming up, Mara.
I can't thank you enough for hosting it, Blitz. I'd love to see more debates where we talk about science. It's
I like
been a
hosting. It
pleasure,
was
Robbie.
easy. For what it's worth, I am going to upload this on my YouTube channel. I don't have a lot there. I don't upload there because I don't want to embarrass people from previous debates forever. But this was clean enough that I think it's worth uploading. I guess we can end it there. I will be uploading this probably tonight, maybe tomorrow morning, depending on how long it takes to upload and download, considering it's about 2 hours. Right. Question of who won. Robby, go ahead.
I just want to say thanks, Blitz, for hosting this. I appreciate it. And Nixy for putting on a good debate and coming through it. This was fun. Something I've never done before, so yeah, it's exciting.
Right. So the question comes, who won? Right? Because I said I was coming in neutral. I actually lied a little bit. I was coming in a little bit in favor of Venus. However, I am closer to Mars now, and the only reason I say that is because 100,000 years is a very, very long time, and I don't know how long humanity will last on a single planet. That's my biggest concern. We are very self-destructive, and having 2 planets is better than 1 means that you have a smaller chance of ending all human life. So, for that reason, I would say that at least temporarily, it would be good to get something going on Mars. Venus does sound like it'd be a nice place to live, though. All right, everybody, thank you guys for being here, for doing this. I'll look for more things to do. I like doing this on a Sunday night. I don't know if it's ideal, but it was nice to do. So I'll look to see, maybe we'll do some more of these in the future. Anyway, I'm going to end the live now. I want everybody to, go follow Nixy if you haven't, go follow Robby if you haven't, and I'll see you guys next time.
Take care. Thank you.
After party at Mitch's.